Hello everyone, we are back again with question number 16. This is 16th question of chapter 1, ICSE grade 10, chapter 4. Let's start. We will always have to remember that whenever we are talking about a meter rule, the weight of meter rule is always concentrated at the center. So if it is a meter rule of, let's say this is 0 to 100, if it is meter rule, its weight will be concentrated at the center, which is at 51. So with that basic in mind, we'll start with question 16. It says a uniform meter rule can be balanced at 770 centimeter mark. So this is the meter rule, right, which is balanced. So when we say meter rule, it says it is balanced at 70 centimeter mark, which means this is 70. The question says that when a mass of 0.05 is hung from 94 centimeter mark. So somewhere here. So this is the mass which is hung, mass of 0.05 kg hung from 94 centimeter. If this is 94, which means from the fulcrum, this distance is 24 centimeter. Question says draw the diagram of this arrangement. So we know from our previous concept of this one that weight is always concentrated at the center. So the weight of the ruler will be here, somewhere here, right? So this will cause the anti-clockwise moment and this will cause the clockwise moment. So this is the place where we'll have 50 centimeter mark. So this is part A, answer for part A. Question says find the mass of the rule. So we have to find mass of the rule. Now, as per the law of moments, we know anti-clockwise moment equals to clockwise moment. But we have to keep it in mind that here we have been provided with mass and not weight. Although that doesn't make any difference because on both the ends we'll be cancelling it out, but it's good to show. So it would be m into, so if you'll see the distance from fulcrum, the distance comes out to be 20. So this is m into, I'll say g because it's weight, into 20. And clockwise it is going to be, how much is that? Mass is 0.05 kg. That will be multiplied with g to get the weight, into distance is 24 centimeters. So this g and g we can cancel directly. So I get mass m equals to 0.05 into 24. This 20 goes in denominator upon 20. So this is divided by 10. This becomes 12. So this is 12 into 5 comes out to be 60. And there are two zeros. So 0.60 upon 10. So answer comes out to be 0.06 kg. That is the mass of the rule, which is as per the answer available. Done. We'll start with the next question now. Next question is question number 17. So we'll start with question number 17. And again for question 17, we have to keep it in mind the concept of the weight of ruler always being in the center. So if this is a ruler which goes from 0 to 100 centimeter, which is a meter rule, so then its weight will always be at the center, which is 50. So it says, question 17 says a uniform meter rule of mass 100 grams. So meter rule is having a mass of 100 gram, right? Is balanced on a fulcrum at 40 centimeters. So fulcrum is at 40 centimeter. Which means this distance from the fulcrum is going to be 10. By suspending an unknown mass m at mark 20 centimeters. So at mark 20 centimeter, an unknown mass m has been suspended, which is 20. So the mass is at the distance of 20. Question says find the value of m. So we know this m will take it anti-clockwise. The weight of the ruler will take it clockwise. So we know for the first one, anti-clockwise moment equals to clockwise moment. So the anti-clockwise moment would be m into g, which is because we have to multiply it with g to get weight, and then distance is 20, and clockwise it is m, which is 100, into g, which is the acceleration due to gravity. We have to multiply to get weight, and then distance is 10. So the g and g gets cancelled. So we get m equals to 100 into 10 upon 20, which comes out to be 50 grams. So first part says find the value of m. We got the mass m 50 gram. Second one, going ahead with the second one, it says to which side the rule will tilt if the mass is moved to 10 centimeter, which means now the mass is at 10 centimeter and mass available is 50 gram and fulcrum is at 40 and the weight of rule is 100 gram mass, which is at 50. So which means this distance is 30, this distance is 10, this is anti-clockwise, this is clockwise. So to which side the rule will tilt if the mass m move to the mark 10 centimeters. Now, in which direction will it tilt? That will be determined whether anti-clockwise moment is greater or clockwise moment is greater. So let's try and find out anti-clockwise moment. Anti-clockwise moment would be F into D. So F here is 50 gram M into G, which is to get, we are keeping it as G only, and D is 30. So this comes out to be 1500. Now with G, I can write it as gram force, and this was in centimeters. So I can write it as gram force centimeter. For clockwise moment, we get M F into D. So F is here, M was 100 gram, that is the ruler. G will remain as it is. And D, when we are talking about it, is 10. So we get 1000 gram force centimeter. Why I wrote gram force centimeter is because G is already available with us. So from this, we understand that anti-clockwise moment is greater than clockwise moment. Therefore, it will, where will it move? It will tilt towards, tilt on the side of M because this is greater, right? So it will tilt anti-clockwise, which means anti-clockwise. So which is what is given on this part also, right? Now question says, what is the resultant moment? So for part 3, resultant moment, resultant would be, let's check, anti-clockwise minus clockwise. What do we get? It's 1500 minus 1000. So we get 500 gram force centimeter, and it is in the anti-clockwise direction. So what is the resultant force? 500 gram force centimeter anti-clockwise direction. Now the question says, by suspending, okay, that is the fourth part. How can it be balanced by another mass of 50 gram? So the question is going like this. So we already have a ruler, right? It is balanced at 40, right? The mass is kept at 10 centimeter. The mass is available, which is of, how much was the mass available? It says our previous mass available was 50 gram, right? Yeah. And previously the weight of the rule is available at 50, which is 100 gram. If I'm not wrong, that is 100 gram. Yes. Now the question says that where will we keep, how will we balance it? So it is moving on the anti-clockwise direction. So which means we will have to keep the mass of 50 gram. So let's say the mass of 50 gram will have to be kept, 50 gram will have to be kept on somewhere this side, right? This side means it could be anywhere between 40 to 100, right? To balance. So for that, we will have to find out. We know anti-clockwise moment equals to clockwise. So anti-clockwise moment we already know, which is 1500 gram. So 1500 gram force. Clockwise comes out to be, when we are looking at it, we have already found for the previous one, which is 1000 gram force plus. What we need to do now is we will have to, okay, the G is already getting cancelled from both the ends. So we will just straight away write that. So we'll not add G value here because it is getting cancelled from both the sides. So now for clockwise, we are adding another mass, which is 50 into, at what distance we are adding. That's what is the question saying. So we will have to find out. So this would be 1500 minus 1000 equals to 50x. So therefore we get 50x equals to, this is 500 So therefore, X comes out to be 10 centimeters. So where will we keeping, where will we keep it? From the fulcrum, it is at 10 centimeter, which means mass has to be kept here to balance it. So that's what is the question asking. Where will we keep it? By suspending the mass of 50 gram at 50 centimeter. This was question number 17. We'll go to the last question of this chapter. That's question number 18. Start with question number 18. Question number 18 deals with the concept of when we say the body is in equilibrium. So body will be in equilibrium when all the forces, the sum of all the forces comes out to be 0, which means all the upward forces equals to downward forces. So let's start with that. It says in figure 1.34, a uniform bar of length L meter is supported at its end and loaded by a weight W kgf at its middle. So as it is in the middle and this whole is L, which means this would be L by 2 and this would be L by 2, right? In equilibrium, find the reaction R1 and R2. So we know since R1 plus R2, as they are in the upward direction, would be equivalent to weight because it is in the downward direction. Coming up to the next one, we also know that clockwise moment would be equals to anti-clockwise moment, right? So you can see this is bringing it in the anti-clockwise direction. This is bringing in the, okay, if you'll see here, this is taking it clockwise. This one will be taking, this force will take it clockwise and this force will bring it, you can see anti-clockwise. So we know clockwise equals to anti-clockwise moment. So R1 into L by 2 also comes out to be equals to R2 into L by 2. So as we can check, L by 2 gets cancelled. Therefore, R1 equals to R2. So when we substitute this here, we get since R1 plus R2 was equals to W, therefore we get R1 plus R1, I can write it as because we got that. So this is R1 equals to W by 2, which is equal to R2. And that's what was our answer, right? So with this, we have completed all the 18 questions from the chapter 1, ICSE chapter 1, grade 10 force. Hope you have seen all the videos. If you have not seen, go through all the numerical videos. And if you have any question, do put it in the comment box. We'll be coming up with next chapter very soon. Thank you. Till then, have a great time. Enjoy learning. Bye-bye.